In this video, we are going to discuss section 3.5. These will be the derivatives of trigonometric functions. There's two limits here that are pretty important, and I'm not going to prove them to you. I'm just going to show you how to work with them, and then I will put a video along with this video of Khan Academy going over why. So if you're curious why, I will show you another reason later this semester, but I would like to not spend, I'd have to spend about 10 minutes or so explaining why this is true, and then really in the end of it, you'll never have to think about that reasoning again. There's another formula that's going to help us out. So I will post an explanation, but it'll be from somebody else. Okay, so if I want to match this, what I'm looking for are patterns. I see that this x and this x are the same with this. So what we're doing when we do these types of limits is we're going to try to create that, but make that x the same thing. So if it's a 4x, I need the 4x to be the same on the bottom. So for a here, what we're going to do is I'm going to introduce a 4 on the bottom. Okay, but if I introduce a 4 on the bottom to make that 4x, so they match, I have to put a 4 on top too, right? Because 4 over 4 would cancel, meaning I didn't change the problem. So this actually means then I can pull that 4 out on top times the limit as x approaches 0. And then now it's sine 4x over 4x. I can now use that identity. So this is equal to 4 times 1, which is 4. All right, so it's going to work out that same way. Each time you just have to make sure that one on top and one on bottom, you're actually doing a substitution. But it really doesn't matter because the reason this doesn't matter is 4x goes to 0 when x goes to 0, just like x did. So there's A. B. Okay, we have the limit as x approaches 0, and then I'm going to show you how to deal with this one. So I'm going to put 3 sine x, 3x over 3x times, and then I'm going to put a 5, and this is going to be kind of weird here, but the sine x for this is on the bottom. And I'd like to match, and what we're going to do, I'll show you in the next step, but I'd like to have a 5x here. So if I have a 5x there, then I also need to multiply, make some room here. I'm sorry if you wrote it down first. But I also need to take account for that 5 I just added onto the top. And the x is going to get taken care of from here. So look, those x's are going to cancel. I'll show you how everything cancels out. Those 5s are going to cancel. And then these, same color. These 3s here are going to cancel, and that would get me back to the original problem. So notice I made it look like it, and now you're maybe wondering, that second set of parentheses, how do I deal with that? Okay, I'm going to bring the 3 and the 5 here. We need to rewrite limit. Make sure we do that. One thing I do want to point out, a lot of you guys were writing like your final answer on this test. You would do something like this. That is not good notation. You got to have something here. Got to have something there. So you would put the original problem there or the last step that you had, but you can't just write limit of x approaches 0 equals. That doesn't really make a lot of sense. Okay, so that 3/5 can be pulled out. I'll put it here. And then I have sine 3x, over 3x. And then this thing, I'll show you how to deal with it. It's going to be 5x on the bottom and sine 5x, but how I can take care of it is I can just do a -1 power. Remember, a -1 power flips fractions over. So that would get me back to the original. Now, a couple things. These were from the limit rules, and these were things that we just kind of brushed by because we just kind of do it in the problem. I can pull this out. I can also break that down to flip over. But I can think about it the way it is here. And this limit's going to go to 1. And then also that limit goes to 1, but it's to the -1. All right, 1 flipped over like that is 1, so this problem is equal to 3/5. So it's a lot of just algebraic manipulation to match this formula or that formula. That's what these problems will look like. All right, what we're going to get into now, it's going to be some memorization. Derivative of sine and cosine, and they actually, turns out the derivative of sine ends up being cosine. This would be using our definition. I won't drag you guys through the definition, but you could use a definition and some trig identities, those rules that if you had me, I told you guys that you just need to be familiar with, not necessarily memorize. But I won't go there. If you're curious, look up definition of derivative sine, and you'll find a video out there. Right, this is what you're going to memorize. This is going to be one of the harder things, I think, to keep straight as you go along. My Calc 3 students are still like have to look up in the air and think about it. Derivative of sine is cosine. Derivative of cosine is negative sine. You've got to get those memorized. All right, we're going to do some derivatives here. To find y prime, notice that I have two functions, so that requires the product rule. So I'm going to write out the definition first. Derivative of the first times the second plus the first times the derivative of the second. All right, so derivative of e to the x is just e to the x times cosine. And then the derivative of cosine, just like above, is negative sine x, so it's going to be negative ex sine x. We don't have to go further, but I want to show you what we would do here if I had to. I would factor out that e to the x, and I can't do anything after this, but this would make my second derivative easier if I had to do it. But we don't have to here. All right, check out b. So b is, I'm going to rewrite it since it's not right under. So the sine we can take care of, but notice there's an x in front of cosine, so that requires the product rule. So the derivative, I'm going to write this out long ways. Derivative of sine, we'll do that. That's by itself, so all I had to do it. I don't have to do a product rule. Minus, and then it's going to be the derivative, and I'm actually going to do plus. The derivative of negative x times cosine plus the, or minus x times the derivative of cosine. That's the product rule here, and then this was just straight up because it's by itself. So the derivative of sine is cosine. Right? Derivative of negative x is negative 1, so I get minus cosine x. And then here this derivative is going to be a negative sign, so it's going to make it a positive x sine x. There we go. We got to do one more. I'm going to shrink this up and just move it to the side because it's going to require a lot more space than I have here. So I'm going to do that. I hope that's still visible. Wow. All right, so let's try this one. This requires the quotient rule. So it's going to be low, so 1 minus sine x, d high, so d dx of 1 plus sine x, minus high d low, or it's, yeah, low d high minus high d low. Okay, so 1 plus sine x. I'm going to run out of room, so I'm going to shrink this up just a bit. Times the derivative, sorry for all that, derivative, so that's high d low. So if you need a reminder of that definition, please go check it out. And I get 1 minus sine x squared. Okay, I take my derivative. All right, so we get 1 minus sine, that's still there. And then what we're going to get in parentheses here, derivative of 1 is a 0. Derivative of sine is cosine. So I just get a cosine x there. Minus, I keep that 1 plus sine x. And then now I have to do derivative of 1 is 0. Derivative of negative sine is negative cosine. Okay, notice this is going to make our life a little easier. Both of them have cosine. So I'm going to factor out cosine x. And what I get left from the first term is 1 minus sine x. From the second term, this minus here and that minus there is going to make a positive, so I'm just going to put a positive, and I get 1 plus sine x. Kind of works out really nice. And then the signs are gone, and I just get 2 cosine x. That thing worked out really nicely for us. If that's confusing how I factored out a cosine, you could just distribute it out, right? Distribute each one and then add like terms. You'd end up in the exact same spot. All right. I just like little factoring tricks because they make life much easier. All right, that's derivative of sines and cosines. Let's take a derivative of our tangent now. Derivative of tangent, the way we're going to think about this is we're going to do, instead of tangent, let's write out that first part. We'll think about it as its definition, which could be thought of as sine x over cosine x, which is going to require us to do the quotient rule. So low cosine x, d high, so d dx sine x, minus low d high minus high d low, all over cosine squared, low squared. Okay, so I keep going. Okay, derivative of sine is negative cosine, so I get a negative cosine squared from this. Okay, and then minus, derivative of cosine is negative sine, so it's going to be plus, okay, so I think something, oh, I made a mistake here. This is going to be the mistakes that you guys are making probably going forward. Derivative of sine is cosine, not negative cosine. All right, negative sine, derivative of cosine is negative sine, so it makes a positive sign. Hopefully that rings a bell for you. That top is equal to 1. So it's 1 over cosine squared x, which is secant squared x. So the derivative of tangent is another one you got to memorize. Derivative of tangent is secant squared. You could always go through this if you wanted to, but in the moment on a test, right, we want every minute counts. So derivative of tangent is secant squared. Right, we have 3 more that you'll have to memorize. 3 more. So we did this one, that one, and that one. That's those derivatives. And then the other ones are similar. This one is similar to the secant with cotangent. So you'll have to memorize all 6 of these. All right, so spend some time, make some flashcards, do whatever you need to do to memorize. I would recommend every time you do a homework problem, you write the problems down. Okay, I'm going to do some examples for you real quick. All right, practice 1. So this first thing is like another setup like earlier, so this should feel familiar. We're going to get, okay, I am going to put a 3 on the bottom, so I'm going to do a 3 times sine, and I'm going to introduce an x, but it's going to get taken care of in the next part. Then this one, oops, I did the wrong way, times, okay, and then I know I'm going to need a 4, so I'm going to put a 4th here, times, and the 4 is going to go on top, and the x is going to go on top too. Oh, wait, it's tangent. When we're doing a limit. So the tangent, let's try to make sense out of this one. Okay, tangent, I could think about tangent being sine over cosine on the bottom. So I'm dividing by sine over cosine, which means I'm multiplying by cosine over sine. So this becomes cosine of 4x over sine 3x. All right, and then we're going to separate that out a little further. So we get the limit. As x approaches 0, I get this 3 over sine 3x. Now we're going to do that thing with that sign there. So the sine, I need a 3. So I'm going to put a 1/3 here to cancel it. And I'm going to put a 3x over sine 3x. Right? And then we just have cosine 4x. I don't need to manipulate that because I can plug a 0 into cosine. So I have that. Notice that things do cancel out to get us back. That x and that x will cancel. This 3 and that 3 will cancel. This 3 and that 3 will cancel. And really, we could just, do you see how this 3 here and this 3 here will cancel out? Right? So I'm going to do that. They're gone. They cancel with each other. And then now we have the limit of each part. So the limit of the sine 3x, oh, and remember we can think about this second one here as flipped over like in our example. So I get a 1 times, this is going to be a 1 to the negative 1, that's this part, and then times cosine of 0, because I'd be plugging in 0. Well, that's 1 itself. The answer to this problem is 1. Now I know the one above I think was a 1 as well, if I remember. Oh, it was a 4. We're okay. I'm curious now. No, it was 3/5. We're good. Okay, forgive me. All right, there's that one. These are a bit complicated. You just got to learn how to manipulate them to put them in the right spots. All right, we're going to find the derivative of this thing. Calculating derivatives. Okay, find this. This is nice and straightforward. Since the plus sign's there, I don't want to use the product rule. The derivative of sine is cosine. The derivative of cosine is negative sine. I can't do anything else. That's all we need to do on that one. 37. Now this is a product rule in a product rule. Ugh. Okay, so let's try it. Y prime is going to be the derivative of x times the first part plus the first part times the derivative of the second. And then this is going to require another product rule. So I'm going to do that part off to the side. Let's wait till we get there, I guess. Derivative of x is 1, leaving me with cosine x sine x. Plus, all right, and then we're going to follow this derivative of cosine sine x. Okay, so this is a product rule. So the derivative of cosine, that works, times sine, plus cosine, times the derivative of sine. That's the product rule. Okay, derivative of cosine is negative sine, so I get negative sine squared x. Derivative of sine is cosine, so I get a plus cosine squared x. Okay, so I'm going to fill that in. I got x, and this is the kicker here. It goes inside the brackets because it's times x. So I get, now I'm going to flip it because I like my negatives second, but it really doesn't matter. So cosine squared minus sine squared x. You can tell there are no like terms. That is my answer. I could distribute my x through here if I wanted to, but that doesn't actually help me in any way. So be careful of product rules inside of product rules. All right, we have one last one here. Okay, cosecant squared. We're going to have to deal with this one. Okay, so how I'm going to deal with this one. There's a trick to this, and my brain wants to go to the trick. But what this is cosecant theta times cosecant theta minus 1. So it's a product rule. So it is the derivative of cosecant. Oh, I wrote that totally wrong. I don't know what I'm writing. Derivative of cosecant times cosecant plus cosecant times the derivative of, and this is a theta, not an x, right, of cosecant. Kind of strange. And then the derivative of minus 1 is gone. It's done. Okay, derivative of cosecant, if we take a look back at our table, that's right here. It's going to be negative cosecant cotangent. So I get negative cosecant tangent theta times cosecant theta plus cosecant theta times, and it's that same thing, negative cosecant theta times tangent theta. Notice all the multiplication is the same, except we have a minus on both. So this is going to be minus 2 cosecant squared theta tangent theta. I just put together everything, right? If I multiply this out, that's how I get my cosecant squares. Then I have two of the same thing, but they're both minus, so it becomes minus 2. Right, I have one last one here. That, again, is just, they want second derivative now. So let's do first derivative. Okay, it's the derivative, it's a product rule, multiplying two functions. So it's the derivative of secant x times cosecant plus secant times the derivative of cosecant. Okay, the derivative of secant is secant tangent times cosecant. Then I get secant times the derivative of cosecant. That's going to be negative cosecant cotangent. Oop, and I made a mistake up there, and you guys probably noticed it then. I said tangent here, but these are cotans. Whew. All right, I'm sorry, guys. These are cotans. All right, there we go. At least we found it in the video, and you guys aren't sitting there mad at me like, you didn't see it. But there it is. Okay, so we have this. And I like to put things together because I don't want to... if I don't want to go ahead and start taking derivatives, because notice it's a product rule within a product rule, and we have to do it twice. So I'm hoping that these things will cancel out in some way. So I'm going to go to sines and cosines. This is 1 over cosine times tangent times 1 over sine. Plus, okay, or minus, let's go and do minus. And this is going to be 1 over cosine x times, that minus I moved out front, 1 over sine x, and then cosine x over sine x. So I get, okay, if you notice that tangent, let's write that as sine over cosine to help us out. Notice that the sines cancel, but I get cosine squared x minus, and then here the cosines are going to cancel, so I get, oh, and this is 1 over, forgive me. My brain's not on. 1 over cosine squared x. And then the next one, the cosines are going to cancel, and I'm going to get 1 over sine squared x. Be careful. You can't just straight up combine them the way they are. How we could do this, let's go ahead and flip over. This is secant x times secant x. There's a rule for this that it will make this much easier. This is going to be cosecant x, cosecant x. Right? I flipped them because they're 1 over. Then I just wrote them out like this. That is my first derivative. They wanted us to find a second derivative. So I tried to get as simple as I could. That way I could do nice and easy product rules by themselves. So d dx of secant x times secant x plus the secant x times the derivative of secant x. Notice they are the exact same thing, right? And that's going to happen on this back part too. So I'm going to go ahead and write it like this, minus cosecant, and I'm going to put a 2 in front of it because it's going to be 2 of them, cosecant d dx cosecant. What I did is I just used the pattern that was showing itself right here, that those are the same, and they're going to become 2. So if I rewrite this, this becomes 2 secant x times the derivative of secant x, right? And then we have this back part. I'm just going to copy and paste because I'm lazy. Cool, there's that. So now I just have to do the derivatives. The derivative of secant is secant tangent minus 2 cosecant, and it's going to become positive, cosecant x. Derivative of cosecant, that's why it became positive, is because it's negative, and I get cosecant cotangent. Usually a negative, but it cancels with the negative out front. That's going to leave me with 2. Secant is 1 over cosine. That nothing's going to cancel there, so I'm just going to leave it secant squared x tangent x plus 2 cosecant x squared cotangent x. And we'll leave it like that. I don't think things are going to cancel. That's 1 over sine. Things aren't going to cancel. They just get a little more complicated. We don't need to go further. We can stop right there.